Lucas Winterberg. I work with U-Spatial. Today's presenter is Michael Moore.
Hello.
Michael works with Flat Rock Geographics here in the Twin Cities, and he's also finishing his master's in GIS at the university. So he's going to talk about introduction to web mapping with Leaflet today, and I'll leave it to you. Thanks a lot.
Thank you. Who has heard of Leaflet already? Anybody not heard of Leaflet? All right. Who's used web maps before? Who's created one somehow? Okay. So we got a lot of people that have done something with them. I was told to make my presentation so that anybody should be able to follow along. There is some coding, but you should be able to copy and paste, and this presentation will be available online afterwards as well. Actually, it's on GitHub right now on my repository, and I'll show a link to that later on. Let's see. So there's a lot of options for making web maps out there. There's, of course, Google Maps, which is very popular. Bing Maps has gotten a lot better in the last year or so. There's MapQuest. OpenLayers has been a popular choice for some time for people who wanted to make their own maps. And then there's Leaflet that has come about in the last several years and really matured. And it's kind of the popular new kid right now. And I've used OpenLayers and Leaflet, and I enjoy Leaflet quite a bit. And for a lot of projects, it's a good tool for the job. So web maps are usually made up of different layers. You'll have base layers, and you'll have vector layers. You can have raster layers even. And so when you load a map online, oftentimes you'll see the map kind of come in pieces like a checkerboard pattern. That's because the map is made up of different tiles. So they'll take a world map, they'll slice it up into little squares. Each square gets a number. And then when you zoom in, those squares are further sliced up. And this is done so that the browser can load parts of the map at once. You don't have to load the entire world. And so they can provide different resolutions. Leaflet and OpenLayers use the standard that was popularized by Google with these map tiles, where the whole world is called zoom level 1, and it's a single tile. And then every time you zoom in a level, you split each of those tiles into 4. So every zoom level is doubled. And most tile sets that you can get, most base maps that you can get, go up to zoom level 17 or 19 or 21. Those are some of the, and that gets you down to where you can see houses and things like that pretty easily. On the right here is a list of a couple of popular tile sources. You can generate your own tiles, but for a lot of types of mapping, it's easier just to use somebody else's. Google Maps has tiles you can use. OpenStreetMaps has tiles. MapQuest has some nice tiles that you can use for free. And Mapbox and CloudMade both have tiles that you can use for free if you're under a certain number of map views per month. Otherwise, you can pay, but you get a lot of customization options with those. Once you've got your base map, then you need to add some things on top. And these are known as, oftentimes you'll want to use vector layers. And that's what we're going to be using today, so that's what we're going to talk about. And a vector layer is a layer made out of points and lines, and you can make polygons out of them. Is this all old news for everybody? Is this new for some people? Old news? Okay. We'll skip past this then. I was told to make it basic, so. So these are the basics. On web maps, if you've got vector layers, they're easier to interact with, to be made clickable, and tie them to pop-ups. So why Leaflet? I like Leaflet because it's got good documentation, especially compared to, for example, OpenLayers. And there's a lot of plugins for it. Those are my two main reasons. It's also about a fifth the size of OpenLayers. It's free, and it's easy to use, and there are pretty good examples out there that you can find. They keep the documentation pretty up to date, and people tend to update their examples frequently. So today what we're going to be doing is building a simple web map, and our use case is going to be for a small business that wants to have its different locations put on the map. In our case, we're going to use my favorite fast food restaurant, Culver's. I was browsing their site, and I saw that they had a downloadable CSV with all their locations, and so I decided to use them for example. So we're going to make a basic web page. We're going to add a basic leaflet map, add the base map, and then add the store locations to the map. This screenshot is the map that Culver's has on their website, and ours will look fairly similar. All right. Who has not made a web page before? All right. Who has? Lucas, I think you underestimated people's abilities today. All right, so we're going to skip past some of this then. We're going to use Notepad++. We're going to use Firefox, and we're all going to do this all locally. We're not going to use a web server, just so that you can try this at home. You don't have to get any environment set up. And so let's see, where'd my Notepad++ go? There we go. So we're going to start by just making a real simple website. And we're going to save this on the desktop in here. So there's our basic website. One second, let me see if I can. All right, this will be a little bit easier. Sorry about that. And we're still recording. All right, so we're going to start with just our simple outline of our website. And the next thing we're going to do is add Leaflet to our website. So if you go to Leaflet's website and you go to the download page, you have the option to either download it to your own site or to use a hosted version. I recommend using the hosted version if you can. If other people, if a visitor to your website has already visited a website that uses a leaflet map, this code will already be cached in their browser and they won't need to re-download it, and that will make your website look a little bit faster. It also means you don't have to download and save those files anywhere. So we'll just throw those in the head section up here. And the next thing we'll do is we will add a new div. The div needs to have an ID, and it needs to have a height. Divs by default have 0 height, which would mean we'd have a 0 height map, which wouldn't be very useful. And so we've got our div. So let's take a look and see what that looks like now. We've just got a little message saying that a map will appear. And it's good to put a message in there for users maybe that don't have JavaScript enabled or something like that. Whatever you have in that div will disappear when Leaflet gets created, when the Leaflet map gets created. But it'll show up there for users who are using screen readers or have JavaScript disabled. We're now going to create a directory called JS. And inside of here, we're going to create a new file, and we'll call it clovers.js. And we'll open that. All right. So we have our JavaScript file, and we're going to include this script at the very bottom of the page because it's going to interact with this map div. And with JavaScript, if you include it before the div has been created, it won't work. So creating a leaflet map, there's a couple of steps. The first one is create a map variable. And I've used the coordinates 45 and -93 that are roughly the coordinates of Minneapolis. And so we're going to go ahead and paste that code snippet into our JavaScript file. And this 8 here, this is the zoom level that we're going to start our map off at. 1 is the whole world, and level 19 would be, you'd be able to see buildings like rooftops really easily. So we're going to start at 8, just somewhere kind of in the middle. And now when we go to refresh our map here, nothing happens. We don't have any content in our map. We don't have any base layers. We don't have any features to show. And so it doesn't know what to do. So we're going to use the MapQuest OpenStreetMap tiles. I like these tiles a lot because they're nice tiles. They look nice. They're well made. They're free to use, and they don't need an API key. This makes it great if you're distributing a project, for example, in an open source project, where you don't want somebody to clone your project and then use all of your API hits for CloudMate or something like that. Unfortunately, the one downside to using the MapQuest tiles is that they use different subdomains than almost every other tile provider. And so we need to use a special set of tile options. Just 1, 2, 3, 4. Most other sites seem to use ABCD, and MapQuest calls them OTile 1, OTile 2, OTile 3, and OTile 4. But if we copy and paste this into our JavaScript file, we're going to set some options in an object, and then we create a leaflet tile layer, and we give it the URL. These letters inside of curly braces will be replaced for each tile that's loaded. Z is the zoom level, and then X and Y are the coordinates. And subdomains, this S, will get replaced with 1, 2, 3, or 4. And usually a browser will only make up to 4 concurrent requests to any given web host at a time. And by giving it 4 different subdomains, now the user's browser can download 16 tiles at a time instead of 4 at a time. Once again, making your site seem faster. So we'll save that, and now let's see if we've made any mistakes so far. Uh-oh. Something's not working, so let's open up our web developer console here. Map container not found. Our container is mapdiv, and I typed it map. There we go. So now we have the start of a map. We can zoom in and out. Our tiles load. And the center of the map is at 45 and -93. And this is zoom level 8 that it starts out as. So one thing you may notice here is that we have, when we add the tile layer, first we create a variable called basemap, and then we call basemap.add to map. This map is our leaflet map, and this is a common pattern in leaflet development, is to create the object that you're adding as a variable, and then calling .add to map. Other mapping services might do it differently, but this seems to work for leaflet pretty well. So now we're going to need some data to display. If we go to the Culver's website, at the top of each page it says View All Locations. They've got a nice little world map here. And they have this POI file. And it turns out that this file is just a CSV file. So we're going to open that up. You can open it in Excel or OpenOffice. Let's take a look at it here real quick in Notepad++. You'll see that there are a lot of empty columns, and instead of running into a problem later, we're going to clean this file up right now, and we're just going to get rid of all of those empty columns. And the easiest way to do that is just to open it up in Excel or OpenOffice and save it again as a CSV file, and it'll get rid of any empty columns for us. So we'll just save this on the desktop into Culver's site, and we'll call it culvers.csv. Use the CSV format. So now if we take a look at it, all of those extra columns are gone. So now we want to load this data into our website. Usually we'd use a GET request and we'd fetch this as a separate file. However, since we're doing local development, our URL is a file location, so a GET request isn't going to work. So we're going to cheat just a little bit. We're going to, should have kept that open. We're going to copy these contents into a new div in the body of the HTML. Usually this wouldn't be good web development practices, but instead of requiring a web server, we're going to do this. And we'll add a little bit of styling so that it doesn't just wrap. If we don't add the styling, we just get a big jumble of text. So we'll just add. We'll tell it to treat all the white spaces as, treat new lines as new lines, so it looks a little bit nicer. So now we've got our CSV data in our website, and we need to use it in Leaflet. If you try to do this, you'll quickly realize that Leaflet doesn't have CSV support, but it does have a lot of plugins available. So we're going to go to the Leaflet website, and we're going to look through. There's quite a long list of plugins, including the GeoCSV plugin. And the GeoCSV plugin allows us to load CSV as a GeoJSON layer. And so we will go and click on this link, download it. It'll bring us to a GitHub page. And on GitHub, we'll want to click the raw button to show the actual file. This is our Leaflet plugin. To use a Leaflet plugin, all you have to do is load the JavaScript file after you've loaded Leaflet. So it can go anywhere after this Leaflet.js file. So we'll save this to our directory. Culver site.js. Save that. And now we will add the new script that we just saved. js/leaflet.geocsv.js, is that right? geocsv.js, okay. So now when that file is included, it will add, it will extend the Leaflet map and give us CSV abilities. If we go back to the Leaflet GeoCSV plugin page, we'll see a list of options and a usage example. If we were using a real web server, we could get the CSV file as a separate call and then load the function, load the data. We're just going to use this part right here. We'll call geo.csv with the contents and set some options. And so we're going to, we have 4 columns in our CSV file, and we want to ignore the third one. So we're just going to call it ignore. We could give it any name we want, and we'll call the 4th one popup. So that relates to, we've got latitude, longitude, culvers in every column, so that's kind of useless, and then the address. All right. Now if we're lucky, we should get a map now with all of the culvers locations on it. But guess what? We've got a bug again. Let's see. It's not reporting any errors. That's the danger of doing the demonstration live. So we get the contents. Let's see if this command works. We'll go into our console and paste that command and see what happens. Oh, okay. I'm not seeing any commas. It looks like we saved our file as a tab delimited file instead of a comma separated file. I wonder if we can just do, can we replace a tab with a comma? There we go. We'll copy that and paste that into the HTML again. That's looking a little bit better. So how's that looking? That's right. It kind of looks like they're taking over. So we've got some options here. We can do some clustering. But before we move on to trying to do some clustering, does anybody have any questions? Any thoughts? All right. So let's try to make our map look a little bit nicer. We're going to, before we do clustering, let's try adding a pop-up so that we know where these are actually located. We can get an address. So we read on the GeoCSV page that it extends the GeoJSON object. So anything that the GeoJSON documentation says we can do with the CSV. And one of those things is that we can add a pop-up if we pass on each feature as an option. So that every CSV item that's added will get this bind pop-up function called with this as its contents. And that pop-up property happens to correspond to the pop-up column that we set. So let's go back to our JavaScript. And we'll add this in here. And now when we refresh the map, we should be able to click on those locations, and we should get an address. So if you have CSV data and you want to get it into Leaflet, it's fairly painless. If you just download and add the plugin. If we wanted to, we could use the ignore property instead. And now, of course, every location will say Culvers. And we could do other things we wanted to in here if we wanted to make this. We could make this be HTML or whatever we wanted. It's a little bit bigger because it's inside of a paragraph now. But let's do something about this mess. Make it look a little bit more reasonable. We're going to use, these are just summarizations of how things should look in case you go and download the PowerPoint. We're going to use the marker cluster plugin. And the marker cluster plugin has its own GitHub page, but we're going to just steal 3 files from them. We want the default CSS, the marker cluster CSS, and the actual marker cluster code. If you see a dash .src file, that'll be the same as the not.src. It'll just be uncompressed, and so it takes up a little bit more space. So we will save these files into our JavaScript file. Save that one. Save that one. And we'll save that one. And then once again, we just need to add that JavaScript after the Leaflet plugin has loaded. So we'll come into our HTML file again, and we'll just add them at the end here of the head. If you were making a real site, you'd want to organize your JavaScript and your CSS a little bit better, but for the demonstration, this should work pretty well. All right, so now, previously with we were making the CSV layer, and we were adding the CSV layer to the map. Now we don't want to add those CSV layers to the map. We want to create a cluster and then add those layers to the cluster. And so we're going to we'll create a new marker cluster group. And then where we added the geo layers to the map before, now we're going to add it to the markers, and we'll add the markers to the map. And the markers is our marker cluster. So now, when we go and look at our map, now we've got some clusters. A lot of times if you're using Leaflet and you're asked to do something that you don't know that Leaflet can do by itself, your best bet is to start by looking for plugins. Look for somebody else that has had the same problem, and then cross your fingers and hope that all the plugins play nicely together. And most of the time they will, but once in a while you'll have to struggle and ask for help on a forum or dive into coding a little bit more. Now, one thing I've noticed is that when we zoom out a little bit, it makes it look like all the Culvers are down in Florida. And we know that's not really true. And so we're going to go and change some options here. Let's go back to our marker cluster page and see what kind of options we have. So we've got the max cluster radius, and the default is 80 pixels. Decreasing it will make more smaller clusters. So I think if we do that, then our clusters, we shouldn't end up with one big cluster down here. We should end up with maybe a cluster up more towards the Midwest, and then maybe one down south. So let's take a look at that option. And let's maybe cut that in half. So the way you pass options into most plugins is you'll pass in a JavaScript object with keys and values. We did the same thing up here with the tile layer, except we made a separate object and passed in the variable. And then down here we'll just pass this in directly. Let's see if that works to just set that like that. I think it is making more smaller clusters, but in the end we end up with the same thing. That's a good question. Not with those words, at least. Let's see. I would suspect that in order to make clustering fast, they may have taken some shortcuts. Mm-hmm. Yeah. I know that this cluster, the marker cluster plugin was made to work with up to tens of thousands of points. And in JavaScript, once you get up to that kind of data, it starts to slow down the browser. So they probably took a lot of shortcuts. Like they may be calculating where to put the next cluster based on these 4 points instead of based on all of the points, or something like that. But at least for shorter, for closer zoom levels, it gives us a better representation of where the clusters actually are located. Yes, we can. Let's go to the Leaflet website. I guess first of all, are there any questions before we try to change the symbols up? Everybody's in love with Leaflet now?
Clarify, everything you've used here so far is open source or free?
Mm-hmm. Yep. It's everything I've done, including the presentations, on my GitHub page. I don't know if there's a place on U-Spatial where it'll be linked to along with the recorded presentation or something like that. Okay. So you'll be able to go there to get the link, or you can copy this down. But yeah, you can download all the sample code and everything. And Leaflet itself is all open source, as are all of the plugins I've come across. I suppose there could be some closed source ones, but not that I'm aware of. Sure. So probably the easiest way to do that would be to connect your Postgres database to GeoServer or map server, and then use WFS. Leaflet has support for WFS. Actually, you can ask for WFS to serve up the results as GeoJSON, and then you just give that GeoJSON URL that ties back to your Postgres server. Give that URL to Leaflet, and it'll treat it like it would a static GeoJSON file. Leaflet also handles WMS, and you can make WMS requests with it.
WFS or WMS, if you have the option, you prefer?
For smaller data sets, definitely WFS. I think it renders nicely. It renders more nicely, and when you zoom in and out, it can use the same polygons. If you've got a ton of data, then WMS lets you. It does all the processing on the server and doesn't bog down the client's machine. Yeah, they both have their place. But anything else before we try to change the look of the markers? All right, let's see if we can do that. So let's go to the API. Actually, I'll bet there will be a tutorial on it. So let's take a look and, oh, here we go. Markers with custom icons. let's see if we can grab what we need out of this tutorial. So it looks like we need an icon. And then what do? When we create the marker, we set the icon in the properties. So let's start by, see if we can just download. Okay, let's grab this image and save that. And let's grab this image and save that. And we'll copy and paste their code. Let's see, if we're going to customize those markers, we'll need to do it before we read in the CSV, so let's do it up here. So we'll create the green icon, and then, let's see. So we're not creating icons one at a time. But I wonder if we put in here, if we say icon, green icon. Let's just try it, and if that doesn't work, then we'll read the documentation. All right, let's see. Did not work. All right, so we'll go up to, so we need to know how to change a marker on a GeoJSON object. GeoJSON, on each feature, oh, there's a separate style. So style is a function that returns, that will be used to get style options for vector layers created. Okay. So let's add in a style function here, and we're going to return that icon. And now, nothing. Let's see. Got our icon. Once again, they're doing it for a single marker, and we need to do it for all of our markers. Set icon. Changes the marker icon. What does this apply to? This is for markers. Let's try I have a feeling this isn't going to work either. Almost did. Alright, so it's trying to download those images from somewhere else. Leaflet.shadow, leaflet.shadow.png. I do, don't I? Okay. So we'll cut those and put them up here. All right. So now it looks like we've planted a forest. Yeah. You will notice that the clusters still have their own icons. And so for that will probably be a cluster setting. So we'd want to go to the marker cluster website again. And let's see, icon. You can provide your own function for creating the icon for clustered markers. Let's see. And that returns a div icon. Let's take a look at an example. These are custom. It looks like they're not creating oh, okay. So what's happening here is every time a cluster gets created, it's calling this function, and they're always creating a div icon with a different class. And so what we could do instead, we could have an if statement and say if the number of child markers was less than 100, use this size marker. If it was less than 10, use this size marker. And if it's more than 100, use something else. So I don't know that we'll do that. I think we are running towards the end of our time here. Does anybody have any other questions on Leaflet in general? Yes?
I noticed you say your map of clusters, culverts with green leaves is beautiful, but are there any other examples of websites that have used Leaflet really well in off their website?
Craigslist does. I don't know that they make it very beautiful necessarily. That's true. That's true. Let's see, how do we get to the map? There we go. Yeah, it looks like they're doing custom sized circles as well. A lot of people use Leaflet, and it's not always obvious that they're using Leaflet. Like we were talking earlier, CartoDB uses Leaflet. And actually, you were asking about connecting with Postgres. CartoDB is a great way if you've got a small data set to get access to your data in Leaflet. You can throw it in CartoDB and have, I believe you can have GeoJSON, or you can interact with it in other ways too. So that's that. That's a crash course on Leaflet, on how to use plugins, and feel free to go and download the tutorial if you'd like to take a look through it. You should be able to run the code on your own computer without using a web server or anything like that. So, Len.
So Leaflet's great. Are you following limitations and things that you still need to think about open or other libraries, or Leaflet just doesn't do very well?
We needed to do WFS with transactions for a customer, and we dove into Leaflet and then had to write our own plugin for WFST. And I'm certain that I didn't cover all of the corner cases. It works for what they need it for, but I think if we were going into another project with WFST, I'd probably go to OpenLayers. OpenLayers is kind of at a tricky spot right now. OpenLayers 2 is kind of getting toward the end of its life. It's very long in the tooth. OpenLayers 3 looks fantastic. It's way smaller, but the documentation is terrible still. It's like, I think it's still in beta, OpenLayers 3. I'm very excited to see what they come out with as it's released, because I think having good competition between Leaflet and OpenLayers will be very beneficial. If you need the kitchen sink, go with OpenLayers. If you need a lightweight map, go with Leaflet. Especially if the plugins can handle the one or two things you need, then you don't have to load this huge OpenLayers 2 file. Yeah? Mm-hmm. Mm-hmm. Good question. So what I would probably do is I would probably store a separate array of each of these features that's created. So I might do something like all Culvers and make that an array. And then for each feature, or maybe even a hash, and then for each of these features that comes in, I would say all Culvers set the feature.id, I think is what it would be, and then set that as a reference to the layer. So once that's run, then in any JavaScript function, I can get a reference to that layer. And so then what would happen is, in my HTML, I would have here somewhere a list of locations, and I'll just do one, and it might be, let's just do zoom to on map. This might have the address in it, or the Culvers, maybe a store ID or something like that. So you'd have to modify your CSV file. And then with that store ID, so let's say this says 2075 East Main Street. So let's say we had a Culver's ID as one of our columns here. Let's change what we did in here a little bit. We're going to change this to our Culver's ID. Then our function zoom to on map could say all Culver's ID. You might be able to do pan to directly. Otherwise, you'd be able to get the longitude and latitude, the coordinates out of this layer object and say map.pan to. Yeah, you can open the pop-up. Once you have a handle on the layer itself, so each marker, in Leaflet, each marker that's thrown up there is a layer. Where'd ours go? Lost it. So each of these markers is a layer, and each of these clusters is a layer. So if you, once you have a handle on the layer, though, you can make calls to open the pop-up. You can make calls to get its coordinates or get its properties, to zoom to it. If it's a polygon, you can say zoom to fit, and the map will zoom to fit the polygon within its bounds. Go to whatever zoom level it needs to do that. And so if you need to interact with a feature, you want to save it off into its own hash or its own array, and then that way you can get a handle on it again afterwards from other functions. Any other questions? All right, that's it. Thanks for coming.